Hey guys, welcome to 2.5 Implicit Differentiation Day 3. In this lesson, we're going to still be talking about implicit with a little bit more applications. And as you can tell, we have a picture of a graph of a relation. It's not a function. Notice it's not a function. It does not pass vertical line test. So let's go ahead and analyze this function. It says here, find dy dx. Well, what's the derivative of y cubed? It's 3y squared times dy dx plus 2y dy dx minus 5 dy dx. Why is y just dy dx when you take the derivative? Well, let's see. Y to the first, bring the 1 down, minus 1, chain rule, y prime. What is a y to the 0 power? Just 1, which leaves you with y prime. The next one, minus 2x. The derivative of something with respect to x, that's x, is just x. Something, you just leave it alone. No need for a chain rule here. And there it is. How many dy's do I have? Dy dx do I have? I have 3. So factor all these out. Dy dx 3y squared plus 2y minus 5. And I'm going to do something here on the fly. It's a very poor job that I'm doing right now. So I'm going to go ahead and just squeeze in there a step in between this step so that it's equals 2x on this side. Equals 2x. Finally, this is a lot more easier than one we did in the previous days. And they don't get as much, they will never get as hard as the one that we did in the previous day. They will not get that hard. And there is my derivative. So this equation, I'm not going to say function because we know it's not a function. This equation represents this graph here. This is the derivative of this graph. Write the equation of the line tangent to the curve at the point 1, negative 3. So why don't we go ahead and look at the graph? Since we have a picture aid, why not? Here is 1, here's negative 3, 1, negative 3 is here. So the derivative, the tangent line, is the derivative that crosses through this point. And notice I did a very good job making it cross at one point. I'm not very good at this, so let me see. Boom, there it is. So the derivative looks like it's a very slight inclination, which means the slope must be very small. So let's find out what it is. Dy dx, when I plug in, x is equal to 1, y is equal to negative 3, I should get 2 times 1 over 3 negative 3 squared plus 2 times negative 3 minus 5. 2 over, this is 9 times 3, which is 27, plus negative 6 minus 5. So this is minus 11. 27 minus 11 is 16, and that is 1/8. And it seems very reasonable that this slope looks like a slope of 1/8, a very slight inclination. I'm not done yet though, right? It says find the equation of the tangent line. I have the point. I have the slope. Y minus a negative 3 is equal to 1/8 x minus 1. And you're done. Find the coordinates on the curve where the line tangent to the curve is vertical. Tangent is vertical. What does that mean? Vertical tangent. Let's look at the graph. I'm going to erase some of this stuff around the graph just so that we can find it, so we can see a clear picture of it. How many points do you see where the graph has a vertical tangent? I see 1, 2, 3, 4. This one looks like it's just to the left of -3, and this one looks like it's just to the right of -3. It says here, find the coordinates of the points on the curve where the line is tangent. The line tangent to the curve is vertical. What does it mean to have a vertical tangent? Okay. dy dx. Let's talk about what it means to have a horizontal tangent. A horizontal tangent means the derivative is equal to 0 because the derivative represents slope, and slope that is 0 is horizontal. Well, what is the slope of a vertical line? It's undefined. So that means we set the derivative and we find the x values that make it undefined. Well, what does it mean for something to be undefined? You got two cases. Number over 0 or 0 over 0. But 0 over 0 is an indeterminate. Number over 0 is undefined. So here's what we need to do. I need to get my derivative. Let me get my derivative. 2x 3y squared plus 2y minus 5. I need to get my derivative and set the bottom of that derivative equal to 0. I'm going to get this and equal it to 0. 3y squared plus 2y minus 5 is equal to 0. Now, I don't know if this is factorable. Let's check it. A, C, B, -15, 2. Two numbers that multiply to give me -15, but when I add them, it gives me 2. So let's try let's try 5 and -3, and that gives me 2. So here are my factors. So it is factorable. So I'm going to write it like this. I'm going to write it as 3y minus 3, 3y plus 5, and that is the same thing as 2. Now you guys are probably wondering, well, 3y does not give me 3y squared. Sir, what are you doing? Well, it does if I factor out a 3. I can divide both sides by 3 of this equation, and I simply get this. Y is equal to 1. Y is equal to negative, well, no, not 1. Y is equal to, I can't do math. What is it? -5/3. Okay, I'm running out of time. These are my y values. Okay, notice I want the points. On the graph, I have 4 points. Obvious, it's 4 points. So I'm going to get this equation and plug in my y values. Y is equal to 1, and y is equal to -5/3. Okay, so let me go back over here. You guys don't have to do this. Well, you don't have to erase. You guys have paper. Okay, if I plug in y is equal to 1, I get 1 plus 1 minus 5 minus x squared is equal to -4. This becomes 2, -5, which is -3 minus x squared is equal to -4. And then I get -x squared is equal to -1. X squared is equal to 1, which is x is equal to plus or minus 1. 30 seconds left. I'm going to have to leave you guys with this part on your own. So that means that when y is 1, x is plus or minus 1. So I have the point 1, 1, -1, 1. And do you see here's 1, 1 and -1, 1. I'm going to let you guys finish off the rest. I found 2 points. Now I need you guys to find the other 2 points. Good luck.